Hello, my name is Arnes Metz. I'm a professor in the Photovoltaics Materials and Devices group at the Delft University of Technology. Welcome to the second course in our MicroMaster series Solar Energy Engineering. The second course is called Photovoltaic Technologies. We advise you to take the PV1X Photovoltaic Energy Conversion course before starting this course. In this course, you will learn all about the design, processing and characterization of the different PV technologies, as well as their advantages and limitations. Let me first introduce the lecturers for this course. I have already introduced myself, Professor Arnes Metz, and I will be accompanied by Associate Professor René van Zwaay. René and I are professors at the Delft University of Technology and work in the Photovoltaic Materials and Devices group. Our group has expertise in teaching and research in all aspects of photovoltaics, from fundamentals to device fabrication and full system design. The course Photovoltaic Technologies is split into 5 parts. After a short introduction, the first 2 weeks will be about crystalline silicon. In week 3, we will discuss the most important techniques used to characterize the performance of solar cells. Then in week 4, we will look into the processing techniques used for thin films. Next, we will spend 3 weeks discussing the different thin film technologies themselves. And finally, in week 8, we will look at the advantages and limitations of different technologies and will discuss some hybrid solar cells that combine multiple PV technologies. Let's go through all of these 5 sections in a bit more detail. The first 2 weeks are all about the technology that dominates the PV industry, crystalline silicon. You will learn about the material properties of silicon, and we will follow the production processes from the raw material all the way to a finished cell and even to the integration of multiple cells into a module. The most important part of this section covers the design considerations to obtain an ideal open circuit voltage, short circuit current density and fill factor for a crystalline silicon solar cell. You will gain an in-depth understanding of the clever design tricks implemented to optimize these solar cell parameters. Over the years, many design concepts have been introduced, some of which have actually made it to large-scale production. In the last part of this section, we have selected some advanced concepts for you that held record efficiencies or had a big impact in the field. By the end of these 2 weeks, you will understand why crystalline silicon still dominates the solar cell market as of today from a technical point of view. After the crystalline silicon section, we will discuss the characterization of solar cells. You will discover that the characterization of the performance of solar cells is an art itself. It is essential to understand how solar cells and modules are characterized to fully understand the practical value of the results. What are the typical standard test conditions, and how do these conditions relate to modules in real outdoor conditions? In addition, a basic understanding of the characterization of solar cells is of great importance when reliability of modules will be discussed in the PV3X course PV systems. In the third part of the PV2X course, we discuss the processing techniques used for thin film PV technologies. These deposition tools are inherently different from the bulky wafer-based fabrication processes used for crystalline silicon. The techniques used to process a material can strongly affect the properties of the deposited material. In this section, you will create an in-depth understanding of the most important tools used for the deposition of the different PV technologies discussed in this course. In the fourth section of this course, we will discuss the most important thin film technologies. We will spend 3 weeks on the thin films in which you will learn all about thin film silicon, chalcogenides like the 2,6 technology cadmium telluride and the 1,3,6 technology CIGS. the 3,5 technology, gallium arsenide, and some organic PV technologies like organic polymers, dye-sensitized solar cells, and the new material, perovskites. Each of these technologies have their specific advantages and disadvantages in some respect. In this section, you will learn about the material properties, module architecture, advantages and limitations of all these PV technologies. In the final section of this course, we will combine and compare the different PV technologies. In this section, you will obtain the skills you need as an engineer to decide which solar cells work best in what situation. We will compare the performance of different PV technologies in terms of their niche markets and market shares. We will discuss their upscaling potential in industry and their projected learning curves for the near future. Finally, we will discuss hybrid solar cells. In these hybrid concept, different PV technologies are combined in order to produce very high performance or very cheap solar cells. All the video content in this course, as well as numerous ungraded practice assignments, are available for free. These exercises are meant to test and improve your understanding of the concepts discussed in the videos, so try the exercises and don't be afraid to make any mistakes. By upgrading to the verified learning experience, you will get access to all exercises, the practice and graded assignments, and the exam questions. All the weekly graded assignments combined count for 40% towards your final grade. There are a total of 3 exams in the course which count for 60% towards your final grade. You can qualify for the PV2X verified certificate by achieving a minimum final score of 60%. We recommend following along in this course with our textbook Solar Energy, Physics and Engineering of Photovoltaic Conversion Technologies and System. This textbook is available as a free ebook for any e-reader on Amazon. Hard copies are also available for purchase at Amazon.com as well as other retailers. Besides the regular content, PV2X also features a live webinar in which you can interact live with the course team. The webinar generally includes a behind-the-scenes tour at TU Delft, an interview with a titan of industry, and an interactive discussion in which the course team treats the issues introduced by you, the students. Look for more information in the webinar tab on the Introduction and Extras section. On behalf of the entire Photovoltaic Materials and Devices team here at the Delft University of Technology, I'm very excited to provide this course for you. I hope you are ready to jump right in and become an expert on the varied landscape of photovoltaic technologies.